Okay, let's change it up a little bit here. So let's talk more about inverse trig. So inverse of our circular function. A circular function is just that repeated function, right? That periodic repeated function. So we want to look specifically at our inverse trig. Now we're going to narrow our output here a little bit because we really want to take a look at what these inverse trig actually have to be. Now keep in mind, anytime I talk about an inverse, right, my inverse has to be 1-to-1 in order to pull this off. So if I want my inverse to be 1-to-1 and I have a periodic function, well, let's write this down first. It has to be 1-to-1 to have an inverse. So when we have these periodic go on forever functions, that is not 1-to-1, right? So in order for that to pull off, we have to restrict the domain. So for an actual trig function here, I'm going to have to restrict that domain. So look at what's happening here with sine. So my normal sine function, we're going along and on, right? So this goes on and on and on forever. Well, that's not going to work because if this is going on and on and on forever, that is not passing that horizontal line test and I'm out. So we know that sine, quote unquote, starts here at 0. So we're just going to hit the maximum and then go back down here to this minimum. So I am going to restrict my domain to just be from here to here, my restricted domain for that maximum and minimum, because beyond that, if it starts to come back down here, then I can no longer work with it because it doesn't pass the horizontal line test. So if I have this minimum, that's good, and taking it up here to this maximum. So if I restrict my domain of my actual sine function, remember your inverse swaps out input and output. So if I'm going to swap out my input and my output here, now 0, 0 is obvious, it's still 0, 0 because input, output. But this point of negative pi over 2, negative 1 becomes negative 1, negative pi over 2. Do you see that? I'm swapping out that input and output. So if I have my restricted domain, now my range is going to be restricted from negative pi over 2 to pi over 2. All right? So that's what we're talking about. When you have an inverse function, it's written like this. Y is equal to sine to the negative 1 power x. Oh, there it is right there. So that's a way to write inverse. This does not mean a reciprocal, right? So on your calculator, you have that inverse function option also. It does not mean that it goes to the denominator. This is just that inverse symbol, all right? It represents inverse, all right? Another way you can write it is arc sine. So sometimes you see an inverse trig as arc sine, and sometimes you see it to that, looks like to that negative 1. It has that negative 1. Both mean inverse. So it's just two different ways to write my inverse trig. All right? Okay, now, here's the deal. I'm going to make this, so remember how we said unit circle is super major. So let's look at our unit circle. If I'm looking at my unit circle, whoop, that's not awesome, but not that horrible, right? It's pretty bad. One more try. Hey, that was not too shabby. Okay, so if I'm looking at my inverse trig here, I know that I have a restricted output. So my output now that I am, where my domain was restricted from negative pi over 2 to pi over 2, that is now my output is restricted here from negative pi over 2 to pi over 2. So when you have inverse sine, your domain is going from -1 to 1, and your range, my output now, is going from -π/2 to π/2. That means on my unit circle, I am over here in quadrants 1 and quadrants 4. This is -π/2 and this is +π/2. All right? So when you are talking about sign, you are only using these values. You cannot use the values over here because those are the values that continue out with my graph. And I don't have that if I'm restricting it to make it an inverse. So I am restricted only over here to this right hemisphere of my unit circle. What if I have something like this? I don't know. I'm just going to create something. I'm going to try to have my inverse sine of, let me go black. I want to find here for example 1, y is equal to arc sine of 1/2. So then you look at your unit circle, right? If I want to have 1/2, my sine of 1/2, this is positive. Remember, anytime you have your trig, you're asking yourself the question, what angle goes with this value? What angle goes with this value? I forgot the word with. Oh my goodness sakes. That's what I'm asking. So what angle goes with a positive 1/2, right? My positive 1/2. So think about our unit circle here, right? I know that I am restricted to just this side. Down here are all negative y values. Up here are my positive y values. So up here, this positive y value, oh shoot, let me try it again, is where my angle measurement's going to hit this. Now, it depends on what you're talking about, degrees or radians. And here, because I'm talking about π/2, negative π/2, we're going to work all of this in terms of radian. All right. Typically, that's what you work in terms of anyway. So whenever I have this value, I'm not looking at this in terms of 30 degrees. I'm looking at this in terms of π/6. So π/6 is that answer. What if, so this was A. What if I had something like C? I want to find arc sine of -2. That's right. Do I have anything? Can I have an input of -2? No. That is not possible. All right. So when you put those restrictions, in order to get our sine, our